In this video, we're going to go over the financial math question from paper 2, May 2021. This is for the Applications and Interpretation Standard SL course. So it says, give your answers in parts A, D1, E, and F to the nearest dollar. That's really important. Believe it or not, so many people would totally skip that part because usually when they're testing, they get kind of nervous. And so they would totally forget about the fact that you have to round those answers to the nearest dollar. Daisy invested 37,000 Australian dollars in a fixed account with an annual interest rate of 6.4% compounded quarterly. Calculate the value of Daisy's investment after 2 years. This is a compound interest problem. You can do this with the compound interest formula that is found in the formula packet, or what's even better is that you can go to your graphing calculator and you can use the finance app from the calculator to get your answers. So on the calculator, you're going to go to apps, enter for finance, enter for TVM solver, and then here you're going to put the information from the problem. It said Daisy invested 37,000 Australian dollars in a fixed account with an annual interest rate of 6.4% compounded quarterly. Calculate the value of Daisy's investment after 2 years. So N is the number of years. In this case, it's 2 years. The interest rate they told us was 6.4%. Present value is going to be negative 37,000. Now, the way the app works is that your present value and future value have to be opposite sign. That is why I'm making present value negative. And kind of the idea is cash flow. If you are going to take your money out so that you can put it somewhere else to invest it, then you are out that $37,000. PMT is payments. It stands for periodic payments. And so right now we're not making any payments. By default, when you clear your calculator before testing, your PMT is going to be 0. Leave it like that because right now we're not making any equal payments. We're just investing a lump sum. Future value is what I'm looking for. Leave it as 0 for now, just because you have to have a value in there in order for you to continue filling out the rest. P per Y is payments per year. Again, leave that alone because we're not making any payments. C per Y is number of times it is compounded per year. In this case, because it is compounded quarterly, then C per Y is 4. And just go ahead and leave it at end. So then we're going to go ahead and go up to future value, which is what I'm trying to find because the question says to calculate the value of Daisy's investment after 2 years. You press alpha, enter, which is solve, and that's going to be your answer. That means that after 2 years, she's going to have $42,009 and about 87 cents. When you do this on the exam, remember that you have to show all your work on your separate answer document. You want to make sure that you write down all of the calculator values. Now, usually that's not the case when you're solving things from your calculator. You don't have to write those down, but for here, that is going to be how you get credit for showing your work. So for part A, I'm going to go ahead and write down that N is equal to 2, I% is equal to 6.4, present value is negative 37,000, PMT, remember we're not making any payments, is 0. Future value is what I'm looking for, so either leave it blank or I'm going to put a question mark. P per Y is equal to 1 because I'm not making any payments. C per Y is equal to 4, and then my answer from the calculator was $42,009.87484 ... And then I'm going to round, and remember, it says to round part A to the nearest dollar. So I'm going to go ahead and I'm going to do that. And I'm going to round this to $42,010. And these are Australian dollars, AUD. So that is going to be my final answer. Then it says after M months, the amount of money in the fixed deposit account has appreciated to more than 50,000 Australian dollars. Appreciated means that it's gained like interest, okay? So it's grown to more than $50,000. Find the minimum value of M, where M is a natural number. That means that you want N to be basically a whole number, no decimals in your answer. So once again, we would do this in your calculator. In this case, you're looking for the number of months, which is time. So in the calculator, before I take you there, N here is basically what I am looking for. Our interest rate has stayed the same. They haven't told us anything about the interest rate changing. It is 6.4, just like in Part A. Our present value is still negative 37,000. And again, you would not write negative 37,000 as an answer, but that is how it works for the app. PMT, we're still not making any payments. PMT is 0. Future value is going to be 50,000 Australian dollars because you're trying to figure out at which point has the account grown to more than 50,000 Australian dollars. P per Y is equal to 1. C per Y is equal to 4. And then obviously we'd have to go back to get N. So let's go ahead and go to the calculator. I'm going back to the top. I'm going to leave N is equal to 2 only because I need a number there. You can't just clear it and then try to press down. The calculator will not go. So leave it at 0, 1, 2, whatever. So then I go down, the interest rate is still 6.4, present value is still negative 37,000, PMT is still 0. This time, future value is 50,000, so I changed that. Then everything else stayed the same, so I go back up to N and I press alpha, enter, and that's going to give me the answer. So 4.7423, remember, that is number of years. So my answer right now is 4.74, but I'm going to have to multiply that by 12 because the question is asking about the number of months. So we got N is equal to 4.7423 ... And then that is something that I'm going to multiply by 12 so that I can figure out how many months that is equal to. So if you take your calculator, and now we're going to go ahead and multiply 4.7423 times 12, we're going to get 56.9. And depending on how much of that number you use, you might get, if you only use 4.74 times 12, you'll get 56.88. I did 4.7423 to try to avoid round off error. I got 56.9. And so this, remember, is supposed to be a whole number. So the answer is going to be 57 months. One of the things that you also have to realize in this particular problem is that the money is growing compounded quarterly. So that means 4 times a year, every 3 months. 57 months is a multiple of 3. So that is my correct answer. Had my answer been 56 months when I multiply by 12, my answer would have still been 57 because of the fact that I have to write my answer in multiples of 3. Had my answer been 57.9, let's say, then that means that the answer would have been after 60 months because it's supposed to be multiples of 3. That is something that a lot of my students do not understand. They just can't fathom, like, why do you have to multiply? Or why does it have to be a multiple of 3? And that is because here the money is growing compounded quarterly, every 3 months. And they're asking you, when is it going to be the first time that there's more than $50,000 in that account? So you wouldn't check every single month, basically. You would check after every 3 months. So luckily here, though, the way they've done the problem, 56.9 is going to round to 57, which you probably wouldn't have checked this whole quarterly thing anyway, and you would have gotten the right answer. Daisy is saving to purchase a new apartment. The price of the apartment is 200,000 Australian dollars. Daisy makes an initial payment of 25% and takes out a loan to pay the rest. Write down the amount of the loan. So there's 2 ways you can do this. Number 1, if she puts a down payment of 25% and takes out a loan for the rest, that means that she has taken out a loan for 75%, okay? So she put down 25%, she's gonna have to finance 75%, which means that I can just go ahead and take the 200,000 and I can multiply that by 0.75 to figure out that the amount of the loan is 150,000. I was able to do that in just one shot. Now, some of my students can't do it that way, which is perfectly fine. What they do instead is that they figure out what is 25% of 200,000 and then subtract. So 25% of 200,000 is going to be 50,000. And then if you take 200,000 and you subtract the 50,000 that you put down as a deposit, you're still going to end up with 150,000. Either way, 150,000 is the correct answer. The loan is for 10 years, compounded monthly, with equal monthly payments of 1,700 Australian dollars. These equal monthly payments tell me that I am going to have a PMT, which is a periodic payment, when I go to put this into my calculator. And so the PMT is going to be 1,700. It says the loan is for 10 years, compounded monthly. Okay, so now it's compounded monthly, not quarterly, with equal monthly payments of 1,700 Australian dollars made by Daisy at the end of each month. I think all of these IB problems are going to be at the end of each month, but obviously read the problem. If it says begin, then you would have to choose begin. But if it's end, then you would choose end. For this loan, find the amount of interest paid by Daisy. Okay, so the way you're going to figure out how much interest is paid on the loan is to think about the fact that Daisy has to pay $1,700 every single month. There's 12 months in 1 year for the next 10 years. Okay, so if you multiply 1,700 times 12 times 10, you're going to get $204,000. So Daisy takes out a loan. She's paying $1,700 every single month for the next 10 years. That's a total of 120 payments. If you multiply that by 1,700, she would have paid a total of $204,000 at the end of the loan. But remember that Daisy only borrowed $150,000. So the difference between what she paid and what she borrowed is going to equal the amount of interest that she's had to pay on the loan, which is 54,000 Australian dollars. And again, that's the business of the bank. They lend you money, but they're earning interest from lending you this money. So for part 2, it says to find the annual interest rate of the loan. So again, we're going to have to go back to the calculator. I'm going to write down what I'm going to enter into the calculator here on the left. N is the number of total payments that you're making. So in this case, you're making monthly payments for 10 years. So that is 10 years times 12, which is 120. And you can enter it in your calculator as 10 times 12 or just as 120. The interest rate is exactly what they're asking me to find. The present value, the amount of money that we have borrowed, is $150,000. Your PMT is the amount of money that you pay every single month, which is negative $1,700. Once again, here, your present value and your PMT are going to be opposite sign because your future value is going to be 0. Why is your future value 0? Because you have borrowed $150,000 and you want to pay that off at the end of 10 years. So after making 120 payments, you want to pay off the loan. You want that loan to go down to 0. And then P per Y is number of payments per year. You are paying monthly, and so the number of payments per year is 12. C per Y is going to be 12 because it told us that it was compounded monthly. So you have to pay attention to compounded monthly. It is just a coincidence right now that P per Y and C per Y are the same number. It is possible that instead of paying monthly, you're making payments annually, in which case P per Y would be 1. It's also possible that you are making monthly payments, so P per Y is 12, but it could be compounded quarterly, which C per Y would be 4, or compounded semi-annually, in which C per Y would be 2, or even compounded annually, in which C per Y would be 1. So let's go ahead and put this information into our calculator. So again, in the calculator, in this case, we said N is 12 times 10. And notice what happens when I put 12 times 10. It automatically multiplies it for me, so you don't have to take that extra step to multiply it yourself. I is the interest rate that we're looking for. Present value, because we took out a loan, then it's 150,000 positive because cash flow. Now I have this money. PMT is how much money I'm paying, so I'm going to make that negative 1,700. It doesn't matter. If you leave present value as negative 150,000, your PMT is just going to be positive. You're still going to get the same answer as long as they're opposite signs. Future value is 0 because I'm trying to pay off the loan. I'm making equal monthly payments, so the number of payments per year is 12, and it is compounded monthly, and I'm paying this off at the end of each month. Let's go back to I, which is the interest rate, which is what I'm looking for, alpha, enter. And so the interest rate is approximately 6.46%. So the annual interest rate is 6.46%. And that's the answer for part 2. And again, all of this work that I have written here, you need to show that on your answer booklet so that you can get credit for showing your work. Side note, you may have wanted to use the compound interest formula for the first part of the question where it was talking about Daisy investing her money, and that would have been fine for you to show your work. However, when it comes to these future value loan types of questions, you will not get credit for putting this into the compound interest formula, which is probably why it's a better idea for you to do them on the Calculator Finance app from the get-go anyway. All right, let's go ahead and finish off the problem. After 5 years of paying off this loan, Daisy decides to pay the remainder in one final payment. Find the amount of Daisy's final payment. Okay, so what has been happening with Daisy? She has been paying this off for 5 years. So I'm going to go back to the calculator. This is for part E. And I'm going to write down that N is 12 times 5 or 60. Daisy has made payments for 5 years. She has made a total of 60 payments so far. The interest rate, if you remember, is 6.46%. It will probably be already still in your calculator, so just leave it there. And then the present value is how much money she borrowed initially, which is $150,000. Her PMT, she's making equal payments of $1,700 every single month. In this particular case, future value is what I'm looking for because I want to find out at the end of paying for 5 years, how much money does she still owe? And that future value is going to tell me what the account has gone down to. Then P per Y, you're still making equal monthly payments, so it's 12. And C per Y, this is still compounded monthly because it's the same exact loan we've been working with. Therefore, C per Y is 12. So let's go ahead and put this into our calculator. So in our calculator, we're going to go 5 times 12 or 60. It's going to do 60 for me automatically. Like I said, because we just found interest rate and it is right there in the calculator, I'm going to leave it like that because it's going to help me avoid round off error. If you were to put 6.46, you should still get the right answer. They should still be able to give it to you. So in this particular case, present value is still 150,000. My PMT is still negative 1,700. Future value is what I'm looking for. I'm going to come back to that. P per Y is still 12. C per Y is still 12. This is why it's so easy, since you already have everything in your calculator, to not copy it down in your work, because since you're doing this fast and you already have the values mostly there, it's easy to just write down the final answer. But realize you need to show that calculator work because that is going to give you points for method, which is points for your work. So now I go back to future value, I press alpha enter, and I get negative 86,972. Remember that number one, you're not going to copy down the negative in your answer. Present value and future value have to be opposite sign. So it is going to be a positive answer you're going to write down. And then we also have to check to see if this is one of those answers that they want us to round to the nearest dollar. So the answer is 86,972.60978. This is part E. And yes, they said part E and part F have to be to the nearest dollar. So that means that when I give my final answer, my future value here is going to be 86,973 Australian dollars to the nearest dollar. Last but not least, we go on to part F. Find how much money Daisy saved by making one final payment after 5 years. If you remember, Daisy was going to pay a total of $204,000 by paying the $1,700 every month for 10 years. Okay, so for paying 10 years every single month, $1,700, Daisy would have basically been paying $204,000. But Daisy has decided that after 5 years, so she has been paying 5 years every month $1,700, and then she gave them a lump sum of 86,973. So if I add that together, that means that what she actually ended up paying was $188,973. So that's how much she actually paid by paying monthly for 5 years, $1,700, and then this lump sum that she ended up paying, which we figured out right now from Part E. So if I take what she would have paid, which is $204,000 if she would have continued paying this off every month for 10 years, and I subtract the total amount she actually did end up paying, I can figure out how much money she saved at the end of the loan, which is $15,027. So by making this lump sum payment after 5 years of $86,973, she's able to save $15,000 in interest. Hope you found this video helpful. Remember to subscribe to my channel for more help with math so that you can say, yes, I can do math with confidence. Until next time, thanks for watching.